Welcome to UV Physics Academy. So here we are discussing Grover's algorithm, and in this fourth part we are going to explain some examples of 2-qubit and 3-qubits. So here first I have taken this 2-qubit, okay, and superposition state or initial state psi naught equal to h tensor 2 operates on 0. Of course here we have 2 qubits. So this is a 1 over root 4. It creates a superposition state from 0 to 3 n minus 1. So that's why a 0 plus 1 plus 2 and plus 3. So any one of these 0 to 3 you can take it as a target. So first one I am taking the target state as a 0. Okay, if the target state is a 0, and already I have discussed this oracle, that means both are 0. So here we have this anti-control, and here we have minus 1 0 1. Okay, so this is a 1 and a 2. So this operation u of 0 comma 1, this 0 is off, 1 is on. So here we have the phase change, so that's why with this you will get 0 will become minus a 0. Okay, that's it. So with this we will get the state as 1 over root 4, sorry, here the 0 is the target, minus a 0 plus 1 plus 2 and plus 3. And the next I am taking this target state as a 1. Okay, so this is nothing but 0 1 in binary notation. Okay, so here it is 0. Okay, for this oracle we have already explained in the earlier video. So here first we have 1, that's why this is the z only. Okay, and here we have anti-control, this is 1 and 2. So here this operation z of 0 comma 1, so which converts 1 to minus 1. So this, with this our final state will become 1 over root 4 after inversion, 0 minus 1 plus 2 and plus 3. Okay, and similarly you can take the third one, that is 2. So I'm taking here target as 2. So the target state as a 2, which is 1 0. Okay, so let me construct the oracle. It's easy, no need to get tension. So here first we have 0, so that's why minus 1 0 0 1, and here control, because 1 is there, that's why control. 0 is there, take anti-control. 1 is there, take control. So with this unitary operator will get 1 and a 2. So here this is a 2 comma 2 plus 1, that is a 3, because it's a control operation. So this is off and on, here the operation 2 2 minus 2. So with this we'll get 1 over root 4 0 plus 1 minus 2 plus 3. So third one I'm leaving this fourth one. Next to fourth one, the target state as 3, we can write it as a 1 1. It's very simple. Let me do this also, but I request you please try, pause the video and try to do it. And this is control z operation, which is 1 here, 2 here, that is a 2 comma 2 plus 1, which is a 2 comma 3, off and on. So here second column contains a minus, that's why here 3 become minus 3. So with this we will get, so we'll get 1 over root 4 0 plus 1 plus 2 and minus 3. That's it. So here we have taken all these states as target states one by one, and I will explain these 4 target states how this diffusion operator operate on this and how I will get the final target state. Let me explain. So let us apply this diffusion operator to this target states one by one. First I am taking the target state as 0 0. Okay, so let it be a 0 in a decimal state notation. Okay, so if this is the target state, when IT operates on psi naught, you will get 1 over root 4 minus 0 plus 1 plus 2 and plus 3. Only target state is a negative and the remaining states are positive. Now here we have this diffusion operator. So this is H2, that means H tensor 2. So here I am using the phase table. Okay, so that is, I hope I have already explained this earlier. With this table, it is very easy to understand this Grover's algorithm. So here I have 0, 1, 2, 3, 0, 1, 2, 3. So this is 0, 0, 0, 1, 1, 0, 1. Actually, this we can use a phase table as well as a head mod operation also. So this is a H tensor 2 or minus 1 whole power x dot z. Okay, anything. So I told you how to construct this table, plus plus because of first 0 and again 0 repeated. So repeat the earlier signs again. So 1 is there, that's why plus minus, 0 came, that's why repeat the same. Next 0 plus plus, 1 came, opposite, 1 plus minus, 1 opposite, like this. Now carefully observe. In this state, we are having the 0 state as negative. Okay, now that means what? Here I am taking this is 0 state into minus. Okay, right? Now I am going to operate the head mod operation here, H tensor 2. Whenever H tensor 2 operates, the normalization factor 1 over root 4 will come. So that's why the first one is 1 over root 4 and one more 1 over root 4. Cool. And after that, see how to do this without matrix algebra. It's very simple. Just add. Okay. So we have 0 minus. See here, I already multiplied with minus. And remaining states are as it is. Okay. Now you just add. Because what you are doing is you are adding H tensor minus 0 plus H tensor, H tensor 2 on minus 0, H tensor 2 on 1, H tensor 2 on 2, H tensor 2 on 3. So then you are adding. I hope you understand. So just add this. Okay. So, okay, let me write this also. Maybe you will understand. Then if I add, here you will get minus. This is a plus. Both cancel. You will get a 2 into 0. Uh, while I am explaining the operator circuit design, I told you after this first head mod here, after this first head mod, you will get the amplitude of 0 state will become n minus 2. Here capital N is a 4, 4 minus 2, it is a 2. If you take 3 qubits, n is 8, 8 minus 2, that is a 6 you will get for 3 qubits. Okay. And the rest of the things here, it is n minus 2 and the remaining are 2 only for any number of qubits. So that's why here it is. So here it is plus 2 into, okay, all other remaining states are having 2 only. Okay, now I am adding this one. So here it is already minus, okay, already minus. This plus minus gets cancelled. Okay, I hope you understand. Then you will get minus 1. Okay, so that is minus 1. Next here, this will become minus. So you can cancel here, 2 minus left. That's why minus 2, already 2 taken common. Next, this become minus. Then, sorry, 1 minute. Yeah, here some mistake. So plus, right. So here this is already minus and these two gets cancelled, so minus 3. Fine. How to remember? Always shall we add like this? Then I will tell you a small trick. It's very easy. I told you the after first head mark, the amplitude of zero state will become n minus 2. It is fixed. That's why it is a 2 into 0. See, after that how I am writing. Always plus 2. Any number of qubits, it is always plus 2 into. How to remember? How to get these phases? It's very simple. After multiplying minus, one more time, after multiplying with minus, what are the phases of 1, 2, 3? Don't see this 0. Only 1, 2, 3. The phase of 1 is minus. 2, again minus. After multiplying with minus extra, minus 3. Like this we will get for any other number of any number of qubits. Yes, I have verified. You'll get it, no doubt. Okay, so that's it. This become we can take 2 common again. So this is a 0, minus 1, minus 2 and minus 3. So this 2 and root 4 gets cancelled and we got 1 over root 4, 0, minus 1, minus 2, minus 3. The next step is very crucial. I have already explained this point in the circuit design class. Okay, so now here we are using one phase oracle which invert the amplitudes of states other than 0. Okay, so that's why this minus came. Here we are inverting the amplitude of 0 state with extra minus. That's why it will invert the amplitudes of the states other than 0. Okay, then 1 over root 4. Now carefully observe, this is a beautiful step. 0. Now this become plus 1 and this become plus 2 and this become plus 3. Now carefully see this table. Okay, so this is nothing but H tensor 2 operates on 0. All phases, all phase factors plus plus plus. So that's why this can be written as this is nothing but H tensor 2 operates on 0. Now again you are operating this is nothing but H tensor 2. Again you are operating this last one. One more head mod operation is there, that is H tensor 2. So the product of these two will give you identity and finally you will get a 0. So only one iteration we have done. That's it, because here only within one iteration we got this answer. Okay, so let us take another example for that. Another target we'll take. Second one, I'm taking target as 1. So in the decimal notation, 0, 1. Okay, so if this is the target, when IIT operates on psi naught initial state, we'll get 1 over root 4, 0, minus 1, plus 2, plus 3. Now I'm going to operate this diffusion operator, which is minus H2. So 2 means here H tensor 2, I naught and H2. Okay, so as usual, one more time I'm taking this tabular form. If still not understanding, I request you please follow. This is very easy to understand the algebra. 0, 1, 2, 3, 0, 1, 2, 3. Plus plus, because here 0, 0, 0, 1, 1, 0, 1, 1. So 0 repeated, that's why same. 1 is there, that's why plus minus. 0, repeat the same. Here 0, plus plus. 1 came next. take opposite. Next 1 plus minus 1 came, that's why take opposite. Okay, so in this target is 1, so here we have minus 1, that's why I'm taking this 1 into minus extra. Okay, now without doing this, please try to say, once you operate head mod operation on this, what is the meaning of that? H tensor 2 operates on 0, operates on minus 1, operates on 2, and operates on 3, and then you are adding all the things. So that's why 1 over root 4, and for this operation one more 1 over root 4 will get. Now tell me, n minus 2, 0 amplitude will become n minus 2, 2 into 0, okay, plus here always 2, remember, please believe me, it is always 2. Okay, if 3 qubits are there, then it is 8 minus 2, here you will get 6 and here you will get a 2. Fine. Now see, after that you will get 1 2 3, then you will get a doubt, then again I have to use this table. Here 2 qubits, it is very easy. If I have 3 qubits, 4 qubits, how to do all these things? No need to get tension. So here you are multiplying with minus, so what is the, after multiplying minus, 1 will become plus, that's why it is plus. Next, after multiplying here, you will get minus 2. Okay, I hope you understand what I'm saying. Don't consider 0, just only consider this. So minus 2, and after that plus 3. Okay, right, fine. Now you can take the 2 common out, so then 2 and root 4 gets cancelled, and finally here we'll get 1 over root 4, 0 plus 1 minus 2 plus 3. Now see here, this is the most brilliant step, and here we are using this phase oracle. Okay, so which will change the phase of this 1 2 3. Okay, so that means we can say like this, x become minus x if x is not equal to 0, then it is 1 over root 4, 0 as it is, minus 1 plus 2 minus 3. Now carefully see the table where you have plus minus, this one. Don't see after multiplying, please see the initial one. So this is nothing but H tensor 2 operates on 1. So I can write this as this is equal to H tensor 2 operates on 1. And again you operated H tensor 2. So this product of these two will become identity and you will get 1. That's it. Okay. So I hope you understand. If you want, I will explain third one, and the fourth one you please try to do it yourself. So third one I am taking the target as 2, that is 1 0 2, right. So if the target state is a 2, then we will get IT operates on psi naught initial state, we will get 1 over root 4, 0 plus 1, and here 2 state phase will change, and plus 3 here. Fine. Now we are operating this head mod H tensor 2. Now I am not using that table. I hope you understand what will happen. 0 state amplitude will become n minus 2, capital N minus 2, capital N minus 2. Okay, so here capital N is a 4, so that's why this will become 1 over root 4, one more factor 1 over root 4 because the head mod 2 times operated. So this will become 2 into 0, and after that here you will get a doubt. So how to get the phase factors? No need to get tension. So here just take H tensor 2 operates on 1 0. So very simple technique. So here first you have 0, that's why plus plus, and 1 came, that's why minus minus. Now these things you are multiplying with minus. I hope now you understand. Forget about 0, minus, plus, plus. So this is nothing but 2 times into plus 1, sorry, minus 1, plus 2, plus 3. So you can take 2 common and 2 and root 4 gets cancelled, and finally we'll get 1 over root 4, okay, 0, minus 1, plus 2, plus 3. And after that the phase oracle, okay. So what it will do, it will change the phase here and here and here. So then it is 1 over root 4, 0, plus 1, minus 2, minus 3. Okay, no need to get tension. So table is not there, then how to do this? So I told you already, this is nothing but H tensor 2 operates on 2. Please check, cross check. Okay, so if you take H tensor 2 operates on 2 means 1 0. Oh, already there, I'm sorry. No need to worry, already we have written here, see here. Okay, so this one, that's good. So here plus plus, minus minus, so that is nothing but H tensor 2 operates on 2. And again one more head mod operation is there, H tensor 2, then this will become identity, and after that you will get 2. So this 1 over root 4 will go to normalization factor. Okay, so that's it. And that means this 1 over root 4 is already included, because this entire thing is nothing but H tensor 2 operates on. Please remember. Okay, that's it. I request you, the fourth one you please try. The fourth one, the target state is 1 1, which is nothing but a 3. So please kindly check this. Now let me take this 3 qubit. Here one time iteration only, that's why it is easy. If a two times iteration is there, then how you will do this algebra? Yes, I will use the same phase table. Okay, so let me clear one thing. We will get, I mean, we can do this algebra in this way very easily. Okay, this just it is an alternate way of doing the algebra. Okay, right? So let me take 3 qubits. Right. So here I have taken this 3 qubit example. So here target I am taking as a 5, 101. Okay, so I have taken this circuit, and here the phase table also I have taken. So this can be written as H tensor 3 as well as minus 1 whole power x dot z. This table I have already explained in the earlier videos. I request you please watch that video. Okay, so now 3 qubits are there. So capital N is equal to 2 power 3, which is equal to 8. So here psi naught equal to 1 over root 8, and this is a 0 plus 1 plus 2 plus 3 and so on. Okay, so including 5. Okay, so now once you operated this inversion operator, so this will become IT operates on psi naught 1 over root 8. Okay, your target state will become minus, that means minus 5 I am taking here, and the rest of the things are positive only, plus 1 plus 2 plus 3 4 and 6 7. Here there is no space, let me write. So I will write like this. This is 0 plus 1 plus so on, already 5 over, and here 4 I will take, sorry, plus 4 plus so on, 7, something like this. Okay, please try to adjust because there is no space. Okay, fine. Now after this head mod operation, diffusion operation. So I told you already, no need to get tension. So this is the head mod operation again. 3 times you are operating. That's why you'll get 1 by root 8 again. So that's why 1 over root 8 and 1 over root 8 I told you. So 0 state amplitude become n minus 2. Okay. So here n is 8, 8 minus 2, 6. If you have any doubt, so please check here. Our target is a 5 and I multiply with the minus. Then if you add, so this is the minus and this is the plus. These two gets cancelled and the 6 plus remains. So that's why this is a 6 0. And the rest of the things all will get a 2 only. So that is plus 2. Now you got it out. What about phases? So for this also no need to worry. Okay. So this is a 6 times 0 plus 2 times remaining. What about the phases? I told you already. After multiplying with minus, here 1 will become plus, minus, plus, plus, and minus, plus, minus. Take those factors. Take those phases. That is plus 1. And after that minus 2. I hope you understand. Plus 3 and plus 4, minus 5. Okay. And yeah, minus 5 and plus 6. Okay. And minus 7. It's nice. Okay. So now what I'm going to do is I will take 2 common. Throughout 2 common I'm taking. Carefully observe. 2 by root 8, that is 8. Okay. Throughout 2 common, so I will get 0. No need to get tension. So 6 I am writing it as 2 plus 4. I am taking 2 common. So that's why here 0 plus 1 minus 2 plus 3 plus 4 minus 5 plus 6 minus 7. And another one more term is remaining, that I am writing it as a separate, that is a plus 4 by 8 into 0. Now I hope you understand why we are taking the phase operation here, I mean phase oracle here. Because before after applying the head mod gate, the phases of 1 to 7 except 0 will become opposite. And again you are applying the phase oracle. Why? Because we want to get back to the same phase of this 5. We'll get back to that. So that means carefully observe. So here I am taking the phase oracle. So this will make, and here I can write it as 1 by 4. So 1 by 4, this is a 0, minus 1, plus 2, and otherwise you can keep it as a 2 by 8 only. 1 minute. Because I want to get 2 by root 8, because I need 1 by root 8. So that's why I'm not changing, I'm not cancelling this. So 2 by 8, 0, minus 1, plus 2, minus 3, minus 4, plus 5, minus 6, plus 7. Now carefully observe please. And after that, that 4 by 8 into 0 as it is. No need to worry. Okay. So that's it. Now see. So here I am writing it as a 2 by root 8 and 1 over root 8, 0, minus 1, plus 2, minus 3. Okay. So let me write 4, 5, 6 and 7 plus 4 by 8, you can write it as a 1 by 2. Now carefully observe the phases of this, I mean H tensor 3 operates on 5. These are the phases. Please see that the top one, plus minus plus minus minus plus minus plus. Okay, so I hope you understand, plus minus, right? So this entire thing, okay, so this entire thing is nothing but H tensor 3 operates on 5. Okay, so let me take this final step again. Just wait. Right. So perfect. So here I have taken that last step. I hope everybody understand. So this thing is nothing but H tensor 3 operates on 5, including that normalization factor 1 over root 8. So now carefully observe. Here we have one more head mod operations, that is H tensor 3. So here H tensor 3 operating, and here also H tensor 3 is operating. So here no need to worry. So this product, these two product will give you identity. So we got 2 over root 8 5. We got the target state, plus now this also no need to worry, 1 by 2. Okay, and H tensor operates on 3. So I hope you know all phases are positive only. So that's why this we can write it as summation x, where x is equal to 0 to 7. But normalization factor will be there. So that is a 1 over root 8 summation over summation x is equal to 0 to 7. Now in this 5 is also there. Okay, I hope you understand this is nothing but a superposition state, which is a psi naught, we can say here 3 qubits. Okay, so now I'm taking common again. So that's why 2 over root 8 plus 1 by 2 root 8 into target, and the rest of the all the remaining states will be having the same amplitude, that is 1 over 2 root 8, 1 by 2 root 8. And in this case here we have the x, but x is not equal to 5. I hope you understand. That means 0 1 2 3 4, but no 5, and next 6 7 all are having this as amplitude. I think this can be written as if I multiply with the 2 here, so this become 4. So 5 by 2 root 8 plus 1 by 2 root 8, and the rest of the states I can say remaining. Okay, and that remaining is not equal to 5. That is the target. Now let us implement this circuit in the simulator, and let us see whether we are getting the same answer or not. Okay, so before going to take this as simulator, let us check whether our answer is right or wrong by using the matrix. We have already iteration matrix, we have already derived. Okay, so let me check. So here we have this iteration matrix. One time we operated, so dit equal to 1 minus 2 by n minus 2 by n, 2 minus 2 by n, and again 1 minus 2 by n. Okay, so if I substitute n is equal to 8, I will get 1 minus 2 by 8. This is nothing but uh, yeah, 6 by 8. It means 3 by 4 minus 1 by 4, and here also 3 by 4, and here it is a 7 by 4. Now this matrix is operating on initial amplitudes, that is alpha naught and beta naught, which are nothing but 1 over root 8. So that's why 1 over root 8, and this is also 1 over root 8, because this is alpha naught and this is a beta naught. Now let us see 1 over root 8 common, and here it is nothing but a 3 minus 1 by 4, sorry, 3 by 4 minus 1 by 4, and this is a 7 by 4 plus 3 by 4. So this is a 1 over root 8, and this is a 2 by 4, which is 1 by 2, and a 10 by 4, that is a 5 by 2. Now see, here we got alpha 1 and beta 1 which are equal to 1 over 2 root 8 and 1 over sorry 5 over 2 root 8. So kindly check whether we got the same answer or not. Absolutely right answer. Okay, so this beta 1 is 5 by 2 root 8 and alpha 1 is 1 by 2 root 8. Now let us check with this simulator. Okay, right. So here I have taken this, and first a head mod superposition 3 qubits, and after that our target is a 5. So we have to create so it is a 1 0 1 1 0 1. That's why here it is anti-control, and finally 1 0 1. So that's why the last we have x z x. I already explained this. I request you please check. And after that we have head mod, because this is the diffusion operator. Okay, and after that we have inversion phase oracle. So but unfortunately here we are taking and this z, here we have x and this is x. So what it will do, it will change the phase of a zero state. Okay, and after that we have head mod. That's it. Now please check this what happened. Minute. Oh sorry, we have 101, so that's why this oracle I have taken this is wrong. Now please check. See 1 0, that's why anti-control here. I cannot show this on the screen. I hope you understand what I'm talking. After first 3 head mod, please check control, anti-control, Z. So why there are no Pauli X matrix X operators on that Z left and right side? Because we have 1 0 1. Wherever 0 is there, then only you have to take left and right Pauli X matrices. That's good. And see, this is the answer. So 5 is the target, and why you got this minus phase change there 180? Because uh, in the formula we have minus extra, but here in the circuit we cannot show that. So that's why we have this minus extra, but no need to worry. And please check 0.88388. So definitely if you see this and this one 5 by 2 root 8, let me check what is this 5 by 2 root 8. So here we have to check 5 by 2 root 8. So this is a 5 by 2 and answer divided by root 8 answer. That's it. 0.8883883476 something. So I hope you understand. Okay. So that's it. If you want, you can check that other one also. That's it. So this is after first iteration. We got this 0.88. Check one more time. 388. Okay, and this 1 by 2 root 8. So here also you got this remaining states. If you observe carefully, the remaining states have 0.17678 point. Right. Okay, so now I would like to take one more time iteration, because one time only we have done. Let us do this. This is also beautiful. Okay, let me write this final state after one iteration in the next page, and I will continue. Right. So here we got psi 1 equal to nothing but a dit, one time iteration operates on psi naught. Okay, so this is our final state after one iteration. The target state amplitude is increased and remaining states amplitude decreased. Now we are going to do this one more time iteration. The first operation is inversion operator. So I am applying that inversion operator. So that is IT. So this is I minus 2 into our target is 5. Okay, so that's why this will become minus 5 by 2 root 8 5. This rest of the things here 2 root 8, and here you have to be very careful. This contains a superposition of all the states 0 to 7. So that's why let me write here 0 plus 1 plus 2 plus 3 4 minus 5 plus 6 and 7. Okay, fine. So here what we are doing is oh, 1 minute. I'm sorry. I'm extremely sorry. So here this is a 1 over 2 root 8. These are the remaining states. There is no 5. Okay, I'm extremely sorry. So these are the remaining states. R is not equal to 5. Now what I'm doing is, here the remaining state amplitudes are 1 by 2 root 8. Carefully observe. And now I'm going to split this as minus 1 by 2 root 8 and minus 4 by 2 root 8. Then again I am taking common 1 by 2 root 8. Then I will get 1 by 2 root 8. Carefully observe. This implies 1 by 2 root 8 common. Okay. Then what you will get? Minus 5 plus remaining states. Remaining states. Okay. I hope you understand. And after that, minus 4 by 2 root 8, 5 as it is. Just I split it. Now carefully observe. Kindly check what is this. Please take that 1 by 2 root 8. So let me write this 2 root 8. Now I think we can write this. Okay, just go back. Just go back here. And this one. The same thing. So first we will operate a head mod, after that a phase oracle, and again head mod. Finally, what is the answer? 5. Okay, so that's why what I am saying is, here no need to get tension. So I have already operated this diffusion operator on this, but on this I didn't operate diffusion operator. So the diffusion operator operated, then what I will get? This final answer. So this is the state after inversion. Earlier carefully observe, try to understand. Okay, so this one, sorry, this one. After diffusion operator, what is the final answer we got? This is the final answer. So here what I am doing is, I am writing this 1 by 2 as it is. After this 5 by 2 root 8, 5 plus 1 by 2 root 8 and the remaining states. Now just wait a minute. So here on this state, separately we have to operate the diffusion operator. That I will do here. Okay, so I will take some small separation here, and now careful. So forget about this minus. Okay, so I'm taking that 5. So yeah, minus 4 by 2 root 8. Okay, so after this diffusion operator. So what is a diffusion operator? We have to operate diffusion operator on this. The first one is H tensor 3 operates on 5. H tensor 3 operates on 5. Okay, so if you see the phase table, or if you forget, you can write like this also, 1 not 1. So that's why starting one is 1, So plus minus, try to understand this. Next is 0 plus minus, again 1 came, so that's why take opposite, minus plus minus plus. So this is nothing but minus 4 by 2 root 8, 1 over root 8, 1 by, oh, because one more factor will come because the 3 times head mod operation. So phase factors are here, the 0, minus 1, no need to get tension, plus 2, minus 3, minus 4, plus 5, minus 6, and plus 7. Cool. And after that, phase factor, phase oracle. So I'm taking this a phase oracle. Then except 0, the remaining states will get a negative. That means this is nothing but uh, minus 2 by 8 I can write, because if I cancel this, so 2 times here, 0 plus 1 minus 2 plus 3 plus 4 minus 5 plus 6 minus 7. I have taken opposite. Okay, and here this is the beauty. Now again I am going to operate this head mod. Okay, so again we have to go back to the tabular form, I mean phase table. Okay, so one more time I will take the phase table. So I hope you understand, we have to add this. That means 0, H tensor 3 operates on 0 plus H tensor 3 operates on 1. Like that, on every state head mod operations will be there, 3 operations. But it's very difficult to do that algebra, but by using the phase table it is very easy. Okay, and here the quite reverse will happen. Earlier 0 state we got 6 times, here you will get a reverse. Here 5 will get 6 times and the remaining states will get 2 times. Let me explain. Okay, so please hold on. Right, now please check, here we have a 2 state minus and a 5 minus and a 7 minus 2, 5, 7. So here I have to multiply 2 with minus and a 5 with minus and a 7 with extra minus. Now if you see carefully, if I add 5, okay, so I told you here fifth fifth state, 5 state, that amplitude becomes 6 times. Of course here you will get a minus. The reason is already one minus is here, that minus into minus again it will become plus, no need to get tension. See here, these two gets cancelled. After this is minus minus minus, this is minus minus, this is also minus, this is a minus 6, 5, and rest of the things just do one, the rest remaining things are same only. So because here it is minus, these two gets cancelled, here it is a minus, these two gets cancelled, and oh, I'm sorry, uh, yeah, these two gets cancelled and here these two gets cancelled. So here we got 2 into 0 plus, you will get plus, and here we'll get one doubt, what about the other? Okay, so these two gets cancelled and these two gets cancelled and here these two get cancelled, but here minus minus, because here you got minus 2, 1. Okay, so like this we have to find, 1 minute, so do it carefully, sorry. So here these two gets cancelled, here minus, here minus, this is plus, this is plus, that's why these two gets cancelled. Next here plus and this is plus, so that's why plus 2, 1. Like this, the remaining all the states will get plus 2 only. That means here you will get minus 6 times 5 plus 2 remaining states, and the remaining is not equal, r is not equal to 5. So let me substitute. So here it can be written as a minus 1 by 4 and 3 times head mod operation, that's why factor 1 over root 8 So I hope you got it. uh, Earlier, I mean, so that diffusion operator is already separately done and we got the final answer. No need to do it again. Just take this and write here. But this one is a little bit careful. Okay. So what you will get 6 times, that too minus 6 times target plus 2 times remaining states. Now please multiply this. This is nothing but a 6 by 4, which is a 3 by 2 root 8, 5, and minus this 2 gets cancelled, 1 over 2 root 8, and this is remaining. Okay. So now I'm combining these two. Just to combine these two. Then you will get this is a 5 by 4 root 8. Okay. So this is a 5 by 4 root 8. And here I can write this as a 6 by 4 root 8 common 5. And next here I have 1 by 4 root 8 and this is minus 1 by 2 root 8. So this is nothing but okay, let me check whether it is right or wrong. Yeah, so 1 by 4 root 8 and this is a minus 2 by 4 root 8. 1 by 4 root 8 and minus 2 by 4 root 8, because just here I multiply with the 2 and here also 2. Okay, so into the remaining states. Now carefully observe. So here finally we got 11 by, so this is our next psi 2 after second iteration. 11 by 4 root 8, 5 and plus, sorry, yeah, plus only. Oh, we should get plus, why we are getting minus? Please wait. No, 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 correct only, absolutely right. So minus 1 by 4 root 8, okay, so into the remaining states. Okay, so if you want you can check this by using the iteration matrix. Let me check with the iteration matrix first. So we have already constructed the matrix, that is a 3 by 4 minus 1 by 4, 3 by 4 minus 1 by 4, 7 by 4 and 3 by 4. Now I am taking the amplitudes alpha 1 and beta 1, which are the after first iteration. After first iteration I have this 1 over 2 root 8 and 5 over 2 root 8. 1 by 2 root 8 and 5 by 2 root 8. So I can take out common this 1 by 2 root 8. Then here 3 by 4 minus 5 by 4, because here it is a 5, and next this one 7 by 4 plus 3 5s are 15, 15 by 4. So this is 1 over 2 root 8 and here minus 2 by 4 and this is 22 by 4. So I hope you got it. So this is nothing but alpha 2 and beta 2 after a second iteration. We got minus 1 by 2 gets cancelled, 4 root 8, and after that 11 by 4 root 8. So this is alpha 2 and this is a beta 2, target state amplitude is increased. Exactly, we got the same answer. Okay. So now if you want to check whether this is right or wrong, let me check first calculator with the calculator. 4 by 11 by 4 root 8. 11 by 4 root 8. 11 by 4 by root 8. 0.972271. 0.97, sorry, 0.97 227 something. Okay, so let us check with this simulator circuit. So here remember, one iteration is completed, next one more time iteration, so we have to consider the first inversion operator, so that's this one, because it is 1 0 1, so that's why 1 here, 0 here, and 1 here, that's why there is no Pauli X. Next head mod means a diffusion operator, one more time we are doing. This will invert the amplitudes of 0 state, and after that again head mod. Now check, exactly same, 0.97227. Okay, so that's it, and the remaining states 0.088. So see here we have that phase change, so that's why no need to get tension, whatever we got, that minus 1 by 4 root 8 is the right answer. This is a 0.88, so 1 by 4 root 8, yes, 0.88388, yeah, 0.8839. That's it. So I hope you understand this. Okay, so we have verified by using iteration matrix as well as that simulator. Okay, so I hope you understand, but I request you please take an example. So kindly do the same algebra. So for target state is equal to 6 1 1 0. So I request you please do this. Once we have done the example, then we get the clarity. So why we are operating the diffusion operator, why we are operating that head mod, after that phase inversion, again why we are operating head mod. So if you have any trouble, so I request you please inform me. Okay, send a message. Okay, so thank you, and I hope you understand. So this algebra, I have explained this 2 qubits as well as 3 qubits in this example. Okay, so we'll meet again in the next video with the 4 qubits example. Then we have to operate one more time extra or two more times extra, like that. Let us check. Okay, so thank you.